proud of your progress. We are doing exceptionally well. We have done 3 out of 6 logic gates. We only have to know 6 logic gates for our IGCSE Computer Science. So what was the first one? The AND gate. And we said AND is multiplication of the 2 inputs. Then we have the OR gate, which is a gate that adds the 2 inputs. Then we had a NOT gate, which is a gate that inverts the input. And we saw that the NOT gate has only 1 input. Do not forget that. It is the only gate with only 1 input. And don't forget the circle in front of your triangle when you are drawing its representation. Now, what is gate number 4? We need to put the last one. So, what is gate number 4? It is the NAND gate. Okay, it is the NAND gate. Oh, what an easy thing. This gate is self-explanatory. It tells you what it does. It's the NAND gate. What does it mean? It is the NOT AND gate. Okay, it is the NOT AND. So it is not of AND. Okay, so it does AND, then it will do NOT. Okay, is the NOT of AND. In other words, you are going to multiply, then you are going to invert the answer. Okay, you AND, then you NOT, then you will get NAND. So this is so simple. You cannot forget this because it's self-explanatory. NAND, NOT of AND. So AND first, then NOT. So what does it look like? First, I'm going to show you what it looks like. Then we're going to do the simple thing. So it has 2 inputs, like any other gate, the input A and the input B. And it will be an AND gate like this, straight at the back with a belly. But before you put the output, you put the circle. And we know we saw this circle on our NOT gate, okay, here. So when we see this circle on our gate, we know it is related to a NOT gate. So this will now be a NAND gate. And what does it do to get the output X? It is just going to multiply the 2 inputs and then it will invert. Okay, so it will multiply the 2 inputs, then it will invert. Now let's do the truth table. What would the truth table look like? Let's put that. So we want to see what the truth table for this guy is going to look like. We are going to have X, the output. We should put it here. And then we are going to have, so we'll have the input A, and then we'll have the input B, and then we'll have the output X. So now let us go and let us do it. Let us put it up. So we have the input A, we have the input B, and then we are going to have the output X. So let's put it. Let's put the whole thing now. Let's put the 2 inputs and their output. Let's show what each looks like. So now, what would be the input combinations? It is going to be 0, 0, then 1, 0, then 0, 1, then 1, 1. Or you can say 0, 0, 0, 1, 1, 0, 1, 1. It's still the same thing, okay? Just like we did here. So it's still fine. If you want to do it the other way around, I don't have a problem with that. 0, 0, 0, 1, 1, 0, then 1, 1. We can stick to that. Now, what would be the output? Let's do it. What are we going to do? Multiply the 2 inputs and then invert to get your output. So what is 0 times 0? It is 0. Then when we invert it, it becomes a 1. What is 0 times 1? Any number times 0, you get a 0. Then what do? You invert it and you're going to get a 1. How good is this? I know you're loving it. Then what is 1 times 0? It's a 0. Then we invert it, we get a 1. What is 1 times 1? It's a 1. Then we invert it, we are going to get a 0. So you multiply, then you invert. That is the NAND gate. Do not forget it. Now we go to the 5th one. We only have 2 more to do. Oh, this is just so easy. We need harder things, man. We need harder things. This is going to be the NOR gate. Oh my. I know that 99.9% of everybody is already knowing what to do. What are we going to do? We OR, then we NOT. So we are going to add, then we are going to invert. It's not of OR. So OR is to add, then remember to invert, and you will get your output. So let's put that. First, let's draw what it looks like. It will have the 2 inputs, A and B, coming in. Then it will look just like an OR gate, which is curved at the back. Make sure your lines touch with get to the end. Don't leave any gaps. Then you're going to do this. Then you put a circle then you put a thing. When I say don't leave any gaps, I mean it shouldn't be like this. Okay, you get it wrong. Make sure it get all the way to the end like that. Then we're going to put your output X. And what did we say it's going to do? X, which is the output, is just going to be, you add them, A plus B, then you invert. Okay, you add, then you invert. Okay, you flip it. So let's do it. So let's put our truth table. Wow, this is just so beautiful, isn't it? Let's put our truth table. Everything is nice. We are loving this. We have A as the input. We have B as the other input. Remember, we have these two inputs. They don't always have to be A and B. It could be A and C. It could be B and C. Okay, in the real problem, in an exam question, okay, it can be. But we are just using them as examples. So these are inputs. Then our output is X. So it's going to be like this. So now, what are we going to have? Let's put a nice output X there. What are we going to have? We are going to have 4 combinations because these gates have 2 inputs. The only gate with 1 input is the NOT gate itself. What are the 2 inputs? 0, 0, then 0, 1, then 1, 0, then 1, 1. Okay? Now let us combine them. What did we say we do? We add. We add first. Then what are we going to do later? We will invert. So let's add. What is 0 plus 0? It's a 0. Then you invert it, it becomes a 1. What is 0 plus 1? It's a 1. Then you invert it, becomes a 0. What is 1 plus 0? Is 1. You invert it, it becomes a 0. What is 1 plus 1? It's 1. We said when you say 1 plus 1, the highest you can get is a 1. You can't go to a 2. Remember, computer science, we are doing binary. Computers can only understand zeros and ones, so you can't have a 2. So 1 plus 1 will remain as a 1. But when you invert it, it becomes a 0. So this is going to be the truth table for the NOR gate. Wow, how easy is it? Then we go to the last gate, which is going to be the exclusive OR gate. We say the XOR gate. Okay, this is just going to be the exclusive OR gate. Now, I'm not going to show you, or I can, but it's not necessary because it's just a waste of time to show you how it finds its answers. Okay, I can show you, but it's just a waste of time. Okay, and because, for the XOR gate, we actually don't like to use the mathematics. Okay, this gate is a nickname. Okay, and this gate is called Mr. One or the Other, but not both. Okay, that's the nickname for this XOR gate. In other words, it is only high when the 2 inputs are different. So one or the other. Okay, so this gate is called one or the other, but not both. So when 2 gates are the same, it will never be high. It will give you a low. In other words, it will give you a 0. When you have a 0 and a 0, it will give you. So an XOR gate, when we put the maths, we can show it like this. That X is equal to A. Then we put a plus sign in brackets like this. B. It just kind of means like X is equal to, here what you do is you say A times B complement plus A complement now times B. Okay. So it's kind of like this. But we're not going to use this. That's not what we're going to use. So we can ignore that. So I can cancel this out to say, okay, for this gate, we don't want to put that because it then just becomes us loving to put these signs, but they don't actually make sense to us because whatever we write in our summarized note is something we are going to use. So remember, this is going to be one or the other. One or the other. One or the other, but not both. Okay, remember, not both. It's not both. So this is called Mr. One or the Other, but not both. So first of all, let's show what it looks like. It just looks like this. You have the 2 inputs, A and B, and then you're going to have your curve, just like the OR gate, like this. And then you are going to come and put another line at the back like this. Another curve at the back, and then it will go to your output X. So what is this? Mr. One or the Other, but not both. So what are we going to do? We put our truth table. It is only high when the 2 inputs are different. That is the other way you can write it. Okay? It means one or the other, but not both. So let's put it. We have A, we have B, then we have our output X. So if we put it like this, what are we going to have? Let's put it, let's draw. I know this is a walk in the park for a lot of you. Oh my goodness. How nice this is, right? You're enjoying? I know you're enjoying. This is beautiful, right? This is just nice. We love school, don't we? School is beautiful. So let's do it. We have 0, 0. We have 0, 1. We have 1, 0. Then we have 1, 1. So when do we get a high? when the inputs are different, one or the other. So 0, 0, the inputs are the same, so it's going to be a 0. 0 and 1, the inputs are different, so it'll be a 1. 1 and 0, the inputs are different, so it'll be a 1. 1 plus 1, the inputs are the same, so it'll be a 0. So this is going to be how you get the XOR gate. Mr. one or the other, but not both. That is it. Okay, so you can also say it is only high when the inputs are different. You can forget this line. Okay, you can say, oh, is it only high when the inputs are the same? No, they have to be different. One or the other. Mr. one or the other, but not both. So here, what is this? What did we say you do on this one? You add, then invert. Okay, then what did we say you do on the NAND gate? You multiply, because you AND, then you NOT. So it is multiply, then invert. Okay, you multiply, then invert. So now, what about the NOT gate? You just invert. What about the OR gate? You just add the two inputs. What about the AND gate? You just multiply the two inputs. And we'd be done with our logic gates. Here are the 6. The AND gate, where you multiply the two inputs, and this is what it looks like. The OR gate, where you add the two inputs, and this is what it looks like. The NOT gate, where you invert one input. You only have one input, and this is what it looks like. Remember to put the circle in front of your triangle. Then the NAND gate, here is what it looks like. It's the NOT of AND. So it is the AND gate with a circle in front. It shows it's a NAND gate. What do? You multiply, then you invert. Okay, for NOR gate, what do? You add, then you invert. Here it is, it's the OR gate with just that circle in front as you go towards the output. Then the XOR gate is called the exclusive OR gate. It is kind of a different one from all these other ones because we are not actually doing anything. We just remember that it is Mr. one or the other, but not both, which means we are only going to get high when the two inputs are different. And when we know this, then we are good with our truth tables. And now we are going deeper into how we actually then work with logic circuits and logic statements. We want to go and see what those are. Okay, we want to go and see what those are, and we're going to be practicing a lot of these things using past paper questions, and we see how we actually apply this knowledge that we now have. All right, goodbye for now. We'll meet in the next video.